Hi everyone, today will be the last lesson for this class, so we will discuss the movement of inertia and the parallel axis theorem. So last lecture we talked about how to calculate the centroid. So for today we'll discuss the moment of inertia. So first, what's the moment of inertia? It measures how much something will resist rotation. Okay. It's used in the bending stress. So you will learn this later in your mechanics of material class. So this one will be the bending stress. This one will be the maximum moment. This one will be your moment of inertia. So today we will learn how to calculate the moment of inertia. It can be about x or y axis. Okay, x equals to integers of y square of d a and iy will be integral of x square times dA. Okay, and the unit will be, okay, you can have a guess what will be the unit. Will be m 4 times or inch 4 times. Okay. How to calculate the inertia? Like we did before. So like we did to calculate the centroid. So first we take small strips like here, dA, and make the strip parallel to axis of inches. Okay, and then we can use moment of inertia equations for desired axis. So x is and then integrate with bounds and everything because everything in terms of x or y. Okay. So let's see an example. You are given an area, found the moment of inertia about the y-axis. Okay. So you are given this equation. You need to find the iy. So Here's the figure. X, Y, here is y, here is dx. Okay. Iy based on equation will be this, and x squared so will be in the bounded in 0 to 1. The dA is y times dx. Since y cubed 3 times equals to x squared, y is this one. So let's replace the y here. Be 0, 1 x squared times okay. So if we finish the calculation, it will become okay. Next question, what's the definition of moment of inertia for an area involves an integral of the form? So the answer should be B. Okay. And then let's talk about the parallel access theorem. Okay. What does this mean? It means a shape's moment of inertia about any axis about the moment about its centroid and its area times the perpendicular distance, okay, squared. If we express in equation, it will be xc plus a times dy squared. If it's iy, it will be iyc plus a dx squared. And the c means about its O centroid. So commonly, when we are calculating rectangular, the equation will be 1/12 b times by h 3 times. So because the rectangular is very commonly used in a beam, so for example here is b, here is h. If you want to calculate the inertia about x, it will be using this equation. But however, if we have the same, same beam but placed in different direction, if we want to calculate its inertia about x, this distance will become b, this distance will become h. So even the shape is same, but this direction is a little bit different, the inertia will be different. So how to use this theorem? So first, we need to divide the cross-section into like the simple shapes. And then locate the centroid of each shape and then recurve the perpendicular distance, okay, to excess of interest. Then let's use the equation or IY equals to IYC and sums X and IY pieces. Let's see an example. Okay, so given cross section of the beam, let's assume this is area 1, this is area 2, this is area 3. Okay, we need to find the Ix. And how? Okay, so let's mark the distance. This is 50. This is another 50. This is 1, 2. Here is X axis, and here the 3. Centroid is just here. So dy1 will be 150 plus 25 equals to 102. dy2 is 0. Its centroid just on the x-axis. dy3 same. xcy equals to this one b. Okay, and pay attention to the unit. Then let's use a parallel theorem. X equals to, for the first, okay, to become second one, the dy is 0, so it's just equals to xc, okay. What about the last one? And then sum everything together, okay. Here will be the final answer. Okay, so the quiz will parallel access theorem for the axis is applied between, the answer should be A, okay, an axis passing through its centroid and any corresponding parallel axis. Okay, that's pretty much for today. Any questions, please email me or schedule office hour,